In this module, we will see how to represent irrational numbers on a number line. Now dear children, you already know the number line. We had represented the rational numbers last year. See, it was 0, 1, 2, 3 and infinite towards right. Similarly, -1, -2 and -3 infinite towards left. And all the rational numbers had a place on this number line. Do you remember? Suppose if I had given you an example 4 upon 5. So you would have divided this into 5 equal parts. 1 upon 4, 2 upon 4, 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5 and 5. See, it was 1 upon 5, then 2 upon 5, 3 upon 5, 4 upon 5 and this number was 5 upon 5 which was 1. Correct? And this point we used to highlight it right there. Point A represents 4 upon 5 on the number line. So we had these rational numbers and already we know all the integers are rationals, the whole numbers are rationals. All rational numbers had a place on the number line. But what about the irrational numbers? We know that there are irrational numbers also now. And these irrational numbers, which are the examples? Yes, you know it, root 2, root 3, root 5, root 6 and so on. All these irrational numbers, they are existing and they should have a place. They should be somewhere. How much is root 2? If somebody asks you, how much is 1? You can always measure 1 centimeter, 1 meter, 1 kilometer, 1 millimeter. You can say that this is 1 unit, right? If somebody asks me or asks you, how much is root 2? We know that irrational numbers are neither terminating nor recurring. We cannot know the exact value, hence they were called as irrational. Do you remember? काहीच करत नाही, terminate पण होत नाही, recur पण होत नाही, काहीच ऐकत नाही. So we had called them irrational. We did not know the exact value. तो अगर जिसका value ही पता नहीं है, if we do not know the exact value, how will we know its exact length? But my dear children, it is very easy. We can find out these irrational numbers and their positions on the number line. And apart from these, there are two types of irrational numbers. These are irrationals and square roots of decimals. For example, square root of 2.9, not a perfect square, hence it is an irrational number. Square root of, see, root of 4. 4 is a perfect square. Root of 4 was 2, hence it was p upon q, 2 upon 1 rational number. But root of 4.1, not a perfect square, and hence its square root becomes irrational. So either these kind of numbers or these kind of numbers. We want to locate them on the number line. We want to check whether they can be located on a number line. For that purpose, we will very quickly look at a right angle triangle, the Pythagoras theorem. So, let us look at the Pythagoras theorem. You all know, children, Pythagoras theorem says what? Hypotenuse square in a right angle triangle. Side opposite right angle was the hypotenuse. And hypotenuse square is equal to side 1 square plus side 2 square. What we have done over here is that we have taken a right angle triangle whose base is 1 unit, height is also 1. This is 1, this is 1. Now, let me write here hypotenuse. We want to find out this hypotenuse. So hypotenuse was BC. Hypotenuse square is equal to side 1 square plus side 2 square is our Pythagoras theorem. So BC square would be AB square plus AC square. How much is AB? 1. 1 square plus 1 square. What is 1 square? 1. 1 square, 1. This becomes 2. So your BC square was 2, taking square roots on both sides. Taking square roots. So obviously BC becomes what? Root 2. And this is what? This BC has now become root 2. I have got the measurement of root 2. This much is my root 2. That means a right angled triangle with a base as 1, or you can say root 1, because root 1 is 1. I had told you 1 is the perfect square. Base as 1 all root 1 and height as 1 gives me hypotenuse as root 2. Very quickly, I will make small changes. Let me take base now as root 2. Okay, just see it very quickly. We'll find it out. Right now, this is one part. Base as root 1, height as root 1, give hypotenuse as root 2. Now, I am just considering this base as root 2. Root 2 does not have a value. And height also is root 1. Let me check again. What will be the hypotenuse? Hypotenuse square is equal to side 1 square plus side 2 square. So the base as root 2 and the height as 1. That is root 1 or 1 you can consider. So let me see. BC square would be AB square plus AC square. And how much is AB now? AB was root 2. Root 2 square plus 1 square. And you know that square and square root get cancelled. Root 2 square becomes 2. 1 square is 1. 2 plus 1 is 3. So BC square is 3. BC becomes root 3. Did I get the value of root 3? So root 2 as the base, 1 as the height gives me root 3. Similarly now, root 3 as the base, 1 as the height will give me root 4. Again, moving ahead, root 4 as the base, 1 as the height will give me root 5. So just understand, remember this concept. Root 1 and 1 will give me root 2. Root 2 and 1 will give me root 3. Root 3 and 1 will give me root 4. And root 4 and 1 will give me root 5. Exactly this concept we are going to use Pythagoras theorem on the number line now and try to find out the positions. So this is what we have taken a number line. Okay, the scale is a very important factor over here. Understand what scale we have taken, or I have taken here for convenience. You will also take the same scale. Larger is okay, but don't take a smaller scale because we want to find out many things over here. So 1 unit is equal to 3 centimeters. Means this is 3 centimeters, 3 centimeters, 3 centimeters, 3 centimeters, right? Like on our graph we used to take. Similarly, so this is 1 unit. We'll consider this as 1. Okay. Now, very quickly I'll draw over here. We had said like that. Root 1 and 1 will give us root 2. So this is 1. Correct? So this is our 1. Let me draw a perpendicular line. So this is what you can see on your screens. The steps we have written. Take an appropriate number line. And then step number 2 is draw a perpendicular at point 1. So this is the perpendicular. With the help of protractor, I'll mark a 90-degree point and draw this. Correct. Now the next step, what you can see, take a distance of 1 unit and mark it on this perpendicular line. So see here children, this much is 1 unit. So I'll take this on my compass. Keep my compass point at point 1 and mark it. So I get this point A. So how much is this 1A? This was 1. This has become 1. 1 as base, 1 as height. The next step what you can read is join OA. OA is the hypotenuse. And how much is this hypotenuse now? Root 2. So this is my root 2. Now, if I keep my compass at point O, take this as the radius and draw a circle. So that circle will be of radius root 2. Instead of drawing a full circle, let me just bring this point A downwards from O. I'll mark OA in the compass. Bring this A downwards. It will intersect at A dash. OA is equal to OA dash is equal to root 2. So did OA dash represent root 2? This much is the distance. This was 1. So I have written a 1. This much distance is root 2. I have written a root 2. Correct? Next, we had also seen root 2 as the base, 1 as the height was going to give us root 3 as the hypotenuse. Now already root 2 base is there with us. At point root 2, again we will draw a perpendicular line. As you can see the steps. Again take 1 unit. See, 1 is from 0 to 1. Very important step. Take 1 unit, means take 3 centimeters and mark on this to get a point B. Root 2 as the base, 1 as the height. This hypotenuse becomes how much? Root 3. Root 2 as the base, 1 as the height. I get root 3 as the hypotenuse. Take this in the compass, bring it down. This point comes as B dash, which is going to be root 3. Again, root 3 as the base, 1 as the height, gives me root 4 as the hypotenuse. This is root 3 as the base. Let me draw a perpendicular line. Take 1 unit, mark 1 unit, point C, join OC. How much is OC? Root 4. Let me take root 4 in the compass, bring it down. Where will root 4 come? You see, even in my figure, in my construction, root 4 exactly falls on 2, because we know root 4 is nothing but 2. This our construction is correct. Continue. Perpendicular 1 unit, hypotenuse root 5. Perpendicular 1 unit, hypotenuse root 6. Root 7, root 8, add root 8, perpendicular 1 unit, join it. This is root 9, will exactly come at the point 3. Do you understand? So this is how we are getting all these irrational numbers. Which numbers? Natural numbers whose square roots can be easily found out on this number line. So we have located all the irrational numbers. There are a few irrational numbers like the decimals that we will be seeing in our next video, I can say, or in the next part of this video. But as of now, all these irrational numbers have been located on the number line. So this is how we have brought all the irrational numbers on the number line. Root 2, root 3, root 4, root 5, root 6. Even the rational numbers. Now see, each irrational number is having its unique. This is only the position of root 2. No one else can have this position. They are having a place on the number line. The naturals or the integers, you can say, or the wholes or the rational numbers, they already had a place on number line. So now our number line is a big number line. It can accommodate all the numbers on it. This number line can have the rational numbers on it. It also has a place. It is also a home for all these irrational numbers. And that is why our number line now becomes the real number line. Why? Because it is a home to all the real numbers, the rationals as well as irrational. The rationals as well as irrational numbers have a place on the number line, means all the real numbers have a place on the number line, and hence the number line will now be called as a real number line. Children, this is a very important question. It is there, you have been introduced for the first time. For the first time, you have learned what are irrational numbers and how to find their positions. So this question has to come into the exams. What you will be doing is that you will write the steps. If you have understood, I have given you the steps over here also. You will write down all these steps of constructions. Follow the steps. Read one by one the step. Watch the video again and again if you want. And you will represent the numbers root 7, root 8, root 5, all these numbers. So you will have to start with root 2 only. So that 2, 3, 4, then 5 you get. Or obviously from 2 also you can get root 5. But you will represent all these numbers till, I think till at least till root 12. You can go on representing. You will try it for your own, on your own as a homework. As of now, this is how we represent the irrational numbers on a number line. That's all for this video. Hope you'll do the construction properly. And this is what is the beauty of construction. It teaches us accuracy, which is very important in life. See children, accurately root 4 has fallen on 2. So in your case, if it is not falling on 2, means some mistake you have done here or there, means you are not accurate. Correct? It takes us towards perfection. So try doing it perfectly. Take the perfect scales, follow the steps, and realize for yourself that you can be accurate. Pinpoint, you should be able to hit the bullseye. That is important. That is what geometry, mathematics teaches us in our life. Have a nice time. That's all for this video. Thank you.